Stop using the DI method or the UV substitution method to do integration by parts. Let me show you a better way to do this using implicit substitution. So with this integral, we are going to put it into the by parts formula. And the by parts formula, to remind you, is simply the integral of u dv is uv minus integral of v du. So u and v are just functions of x, and this is already in a differential form. Because if, for example, v is x squared, you'd be writing like u dx squared, etc. So if I can rewrite this in this form, I can just apply this formula. Because e to the x has a very nice property of being its own derivative and primitive, I can rewrite this e to the x as d e to the x. Because derivative of e to the x with respect to x is e to the x. The differential of e to the x is e to the x dx, which is this part of the integral. And then I just apply this formula. This is u is the x, and e to the x is the v. So this is x e to the x uv minus v e to the x dux. And that's just a trivial integral, e to the x plus c. Now the DI method and writing out uv explicitly might help in either your school trials if your teachers demand this uv substitution, or in an integration bee where speed is king. But for the HSC, DI method is strictly looked down upon, and they do accept this working out. So at least try it.